Okay, for section 3, we're going to look at the tangent line problem. Now, when I talk about, well, what is a tangent line, first off? Yeah, a line that just barely touches once. Not what the tangent curve looks like, what's the tangent line? Tangent line will go along, usually they talk about it in relation to a circle. It's a line that goes right and barely skims the circle as it goes past. It's a straight line that does that. Okay? So, the idea of calculus, one of the main concepts in calculus, looks at those tangent lines. Now, this is to a graph. The idea being that your graph doesn't have to be a straight line. It can be x to the third, it can be x to the 15th. It has a curve in it. Okay? So, as you go on in calculus, the biggest thing is that you're looking at a rate of change. Well, what's another word for rate of change? Slope. Okay? And that's what this is getting at. We're going to find the slope, but not just of a regular line, of a curve. Well, the problem with the slope of a curve, it's changing constantly, right? So what they do is they take a snapshot. They look at one point on that curve and figure out what the slope would be at that point. So they figure out what the tangent line is. So you have a tangent line that's at that point, this would be a tangent line at this point, this would be one at this point. Each one of those lines has a different slope, right? So the idea is to figure out some commonality that those all have. So that's what we're going to do for this section. Okay, so to determine the rate of change, we're going to look at that tangent line on a single point. That's basically what I just talked about. So whatever that function is, and the point x1, y1. So here, what do you know about these slopes of the tangent lines here? How do they differ? First one will be positive, second one's negative, and third one's 0. Okay, so you have positive slopes, negative slopes, 0 slopes. For this, I can approximate the slope of this graph by using this line that appears to be tangent, and then going from this point to this point. Well, this coordinate's obviously 1, 1. What would this one be? 2, 3. So by using those two, I can figure out what the slope of this line is, and that would be the slope. What would be that slope, real fast? 2. And you'd say at the point, what? 1, 1. So that's the approximate slope of the graph, f of x, at that point. Does that make sense? So if I find the slope, because it intersects here one time, okay, then I can assume, and if this line is tangent, which it appears to be, if it touches only there and never again, then the slope of this line should be the same as the slope of the curve at that exact point. Okay, that's why we're using the tangent line. Now, you can actually get this concept here. Now, you can't approximate the slope at a point by creating the graph and then roughing in a tangent line, eyeballing a tangent line. But to be more accurate, what you actually want to do is think about a secant line first. Now, a secant line touches a curve more than once. So if I look at these 2 points and I'll draw a line between those two, I get a secant line. Now, that's not going to approximate the slope very well, but the idea is, if this is x and f of x, then I go over some arbitrary amount, let's call that h. This x would turn into x plus h. Okay? The f of x would turn into f of x plus h. You just plug in that value to get your y value, right? So, in other words, my difference from here to here would be just h, right? And the difference from here up would be that y value minus this y value. Well, what's the equation for slope? How do you describe slope? Rise over run, or, change in y over change in x, right? Oh, okay. If you look at this, the change in x would be x plus h minus x. In other words, h. The change in y would be f of x plus h minus f of x. Well, what is that? Probably, considering we spent the last 2 days on it. What's it called? Difference quotient. That is literally just your difference quotient. If You take those values to find that slope between any 2 points. That's actually all the difference quotient is, the slope. It looks different, but it's just the change in the y values divided by the change in the x values. And the thing is, what we're going to do with that, though, is to take that h value and keep making it smaller. Because if you keep making it smaller, eventually, it becomes a tangent line. Well, how do we keep making the h smaller and smaller and smaller? What? Through the limit. Yeah. This is a limit as h is going to what? 0. So it's literally just what you guys did yesterday. So if you want to find the slope of a graph, all you do is limit as h approaches 0 of the change in y with the change in x. Does that make sense? So that's what you've actually been doing, is finding that. So if I want to find the slope of this graph, excuse me, at the point 2, 8, I'm just going to go through what we did before. Limit as h is approaching 0. What would f of x plus h look like? Now you could do 2 plus h cubed. Actually, I would just leave it as x and deal with the 2 later. Because I'm going to do x plus h cubed. Replace the x with x plus h, right? So for all of these, we're going to use that limit formula up here. So plug in the x plus h and then just write down the other formula. So that's going to be minus x cubed all divided by h. But technically, the denominator should actually say x plus h minus x. But every single time, you're just going to end up with h. So then ignore that part. How do you do x plus h to the third? Remember that's an expansion of binomials using Pascal's triangle? Then what else? Minus the x cubed. Okay, all over h. Well, the x cubed and the negative x cubed will cancel each other. You can pull 1h out of everything, so I'm still going to have h going to 0 in a second. So 3x squared h plus 3h squared x plus h cubed. Take 1h out of every single term, and you're left with what? Well, 3hx, right? I might have said it, I just couldn't hear it. Plus h squared. Then what? Now you can plug in 0 without it being a problem. If I plug in the 0, what do I have left? 3x squared. 3hx will go away, h squared will go away. You're left with 3x squared. Now the reason I like doing it this way, you could plug in the 2 plus h here, and that's fine. I think the book does it that way to start. I don't bother with that because, honestly, this will find you the slope anywhere on that curve, on the curve of x cubed. I want it specifically at 2, 8, so what would I do? Plug in 2. 3 times 2 to the second is 12. So your slope is 12 at 2, 8. That'd be your answer. Questions on that one? And if you draw it, you can actually see it pretty easily. X cubed looks roughly like this, right? If here is 2, 8 would be about here. Slope should be pretty steep there, right? Well, it's not the scale, but think about it the way that the slope would have to be. If I eyeball the tangent line, is that a fairly steep slope? It's not exactly the scale, but the idea is it should be a fairly decent-sized positive number. It's not going to be 1/2, right? If you really like, you can draw on your calculator, but most aren't going to take time to. Okay. Let's do another one. Okay. If my screen wants to cooperate. There we go. Now this one's kind of contrived. What's the slope going to be? Of the slope, or of this at 4 would be just be -3. Because this is a straight line, that works. What this is trying to get the idea across is if I do that same process here, you're going to get the same thing. Now, one thing to watch out for, when I minus something like this for f of x, make sure you put it in parentheses. It'll make you less likely to screw up a negative sign. And judging by the last test, some of you do need to do that. Okay? So, considering the people that miss half point, there's usually a negative sign. So when I subtract there, I'm going to distribute the -3x minus 3h. I'm going to distribute the negative sign. And then what cancels? So you're left with, you have -3h over h, and since h is going to 0, -3. It doesn't matter where the point is. Technically it's -3 at x equals 4. No, it's got to simplify out first. I'm sorry, I didn't actually finish. Well, no, I did, but these will cancel off. Then if you do the limit as h approaches 0 of -3, it's just -3. Okay. Now, some of you written like this. This is where you wouldn't plug in the numbers specifically. You could do the 2 plus h on that very first example we did. Okay, because it said you're going to use x as 2. This is actually asking for two different ones, and first it asks you to find the formula of the slope. Okay? Go ahead and do this one. What do you end up getting for a formula?
Whoa, I'm not ready. Oh,
2x. Just the formula. You should end up getting 2x. Okay. So replace just what we did before. Replace the x with x plus h. That's the top left. So x plus h squared minus 2. Then minus the original. Make sure you put in parentheses so you don't screw up negative signs. Put it over h. Excuse me. So, FOIL this. FOIL x plus h times x plus h. Or expand the binomial. Okay? That'll give you x squared plus 2xh plus h squared. You still have the minus 2 there. Also distribute the negative. Gives you negative x squared plus 2. The x squares go away, the negative 2 and the positive 2 go away. Still over h. Rewrite it, you have 2xh plus h squared divided by h, 1h out of everything. You have 2x plus h, and the limit of x is approaching, or h is approaching 0, gives you 2x. Say again? That's the formula. The original formula is that limited h approaches 0 is the difference quotient we did yesterday and the day before. That's the formula to find the slope, the formula for the slope. After you make it no longer an issue. Right here it's an issue. Because h is still in the denominator. Okay. Am I done? So if I plug in, I am asking two different ones here, right? So what's your first slope? So m equals -6 at -3, 7. And what's your other slope? At 1, -1. Okay. Now, this is actually something called the derivative. You've probably heard the word. Usually math teachers say it by accident when they're trying to say determinant. They'll say derivative. For derivative, the idea is that's the name of this formula. For x squared plus 1, you actually end up with the slope of 2x. That's what's called the derivative. Now, they'll notate it by saying f prime of x. Okay, so if you want to find the formula, if you want to find the formula of the slope, all it means is you're looking for f prime of x. If you see f prime of x, that stands in for this entire formula. But that's just the difference quotient, yeah. Yeah. That's the derivative process. Taking that and then applying it is basically all calculus 1. Is applying that concept, the derivative concept, to a bunch of different situations. That's the focus of Calc 1. Well, anything where your rate of change is not a constant, where it's not a straight linear line. So pretty much everything, yes. To solve most real-world situations, to get exact values for, requires calculus. If you want the math to be accurate, and not just an estimation. Okay. 10 minutes left. Let's do. I'm gonna stop there. We'll look at the second half. We'll get about 3 more examples. We'll look at those first thing tomorrow. I'm going to give you the last 10 minutes to work on some of these and do some of these, because some of you, considering there was no questions, tells me you didn't do some of the later half of yesterday's homework.